Hello, welcome back. I am Balaji Murthy, Physics faculty. Today we will discuss one other important topic which is relative motion. I will discuss the relative motion in one dimension initially, then we will go for the two dimension. So here, to explain one dimension relative motion, I have taken one simple example. There are two particles A and B. A is thrown vertically upward with the initial velocity of 50 meter per second, and B is just dropped, that is, its initial velocity is zero under the acceleration due to gravity. So G is acting on both the particles in downward direction. The question is asking you that from the ground at what distance both will cross each other. Here I am not drawing A and B along the same line. That's why we don't discuss about the collision of A and B. They are on the parallel lines. And to find out the time of collision or time of crossing and the distance from the ground. To solve such kind of problem, it is easy to consider relative motion. What is relative motion? Here, we are considering one of the particle at rest with respect to other one. So here, for example, if I take observation from particle A, the initial velocity of particle A with respect to B can be written as UAVB. Anything which is going is considered in upward direction, we take it positive, and in downward direction, we take it negative. So, initial velocity of A with respect to B is initial velocity of A minus initial velocity of B. This is simple way of writing by considering B as constant. We are observing with respect to B. So, initial velocity of A here is plus 50 in upward direction and minus B is 0. Therefore, initial velocity of A with respect to B is plus 50 meter per second. Similarly, because we are dealing with a distance, here acceleration of A with respect to B is equal to acceleration of A minus acceleration of B, which is equal to minus of G because G is acting downward, minus of G. So acceleration of A with respect to B becomes 0 meter per second square. That means relative motion here is, it comes under accelerated motion with constant acceleration. Therefore, we can use equation of motion to solve this kind of problem. So now, by second equation of motion, we have relative motion, relative distance of A with respect to B is equal to velocity of A with respect to B into time when they will cross each other plus 1 by 2 acceleration of A with respect to B into t square. Since acceleration of A with respect to B is 0, therefore this term comes out to be 0. Displacement of A with respect to B here is 100. Velocity of A with respect to B is 50 into t. This is 0. Therefore, t is 2 seconds. That means after 2 seconds, they will cross each other like this. Maybe here or here, like this. Okay, that is the answer of the time when they will cross each other. Call it as equation number 1. Then the distance from the ground where will they will cross. For second answer from the ground, we get a displacement of s. We are simply using second equation of motion for particle A. Displacement of A with respect to ground equal to initial velocity of A into t and minus 1 by 2 g t square. Minus is because g is taken negative. So therefore, from the ground is initial velocity is 50, time is take 2 minus 1 by 2 into g taken as 10 into 2 square. So here 2 get cancelled. It becomes 100 minus 20 is 80 meter from the ground. So answer of the second question is they will meet at 80 meter above the ground. At that time, if question is asking at that time what is the velocity of B, so final velocity of B is given by first equation of motion into initial velocity of B minus g into t. So it comes out to be 0 minus 10 into t. Velocity of B when they will cross is equal to minus of 20 meter per second. Similarly, we can find out velocity of A at the time of crossing. That is, here velocity of A at the time of crossing is initial velocity of A minus gt, which is equal to 50 minus 10 into 2, which is equal to 30 meter per second at the time of crossing. Okay. So this is the way in one dimensional relative by using one dimensional relative motion by second equation of motion we can solve such kind of problem easily. This part by relative motion we can solve it very easily. So in our video, if you understand some questions or please comment and share this video with the others. And if you like such session, please like it and let me know which other type of problem shall I solve for you. Till then, see you soon. Thank you.